All right, 9.5. We are going to be looking at applications of the integral, as the title states, and we're really just looking at two applications. And the reason that this is in chapter 9 and wasn't maybe, where we did other applications of the integral is we're going to need parts to solve this. So you read through the book, through the 9.5. And I just want to do a couple examples for you. So one of the definitions that you saw in the book was this definition of present value. Okay, so the present value, and they did a pretty nice job in the book about talking about, where this comes from and how we add this all up. But present value is from T1 to T2. Those are time periods, right? K of T, e to the negative r, T dt. Okay, and so where K of T here, let's kind of define a couple of things here, is the continuous income stream or whatever we're dealing with, but it needs to be a continuous, sometimes I have to sound it out, income stream. And this will be, this continuous income stream will be annual rate of income at time T. So annual rate, okay, at time T. Okay, some other things in here is going to be the percentage rate, the annual interest rate at which, we expect something to grow. Maybe inflation, whatever is going to cause the money to grow. And then T1 to T2 is the time period that we're going to be looking at this at. And remember where this all comes from. In Business Calculus 1, we talked about the famous PERT equation, right? Where if I have, an amount of money invested, let's say an amount P, and I'm investing it at an interest rate of R over a time period T, and I'm compounding that interest continuously, this is the amount of money that I would have after that amount of time period, right? So when I'm asking for the present value, and if you took, business calc from us or from me last semester, we did a problem like this. And the idea here is, like how much money am I willing to invest? This is my unknown now in order to get A. So P equals, if I solve for P, the present value of that money would be something like this. Okay, and so what we're going to see this as is basically like, what is the present value of this company, or what is the present value of this machinery, or what is the present value of this contract that someone's going to sign based on how it's going to grow over so many years. Okay, so let's do one. This should be fun. Okay, so example I have here, a company expects, kind of a lot of writing in these, but that's okay, right? Not that we like English better than math, but sometimes you have to explain things. It's income during the next 5 years okay, to be given by this function. Whoops. And I'll call this function K of T equals 100,000 and multiplied by T. And of course, this is just for T between 0 and 5. And if you look at this equation, this really just says that the company expects its income to grow $100,000 per year, right? It's a continuous growing now, okay? So in assuming an inflation rate of 5%, can the company claim can the company claim that the present value of the income is at least $1 million? So the present value of its income is at least $1 million. Right? So what can this company claim about its worth right now? Knowing about how it's going to grow in the future, what can we say a present value of the company would be as it grows to the future? Okay, what is this company's income worth right now? We know how it's going to grow. We know how much it's going to grow per year. We did this before, we could even figure out how much money it's going to make, right? Or its income, not make, but its income over the next 5 years. But what is the actual present value of this income, right? We could figure out how much I'd make in the next 5 years in income, but what is the present value of it? Why would I, if I wanted to convince someone to invest in my company, maybe I could say, but here's the present value of my income. Here's what I'm going to be, this is really what you're investing right now, and this is what we are going to make eventually. So I'm going to take that K of T, I'm going back to that formula that we just had. I take that K of T, which is 100,000 T, e to the negative R. R is 0.05. Remember in mathematics, anytime you use a percentage involved in like an equation or something, you must write it as a decimal. So 0.05, and then of course I integrated from 0 to 5, okay? Just to make things a little bit easier there. So, whoops, I guess I only have 19% left on my battery. What I need to do is I need to integrate this by parts. So what I'm going to do first, and I think this is the easiest way, is to maybe bring out that 100,000, 0 to 5, t e to the negative 0.05 t, and then I can kind of figure out, I can worry about this 100,000 later, and I can just kind of focus on this for right now. So if you look at this, the integrand right here, I'm going to use parts to do this. Hold on. This line right here is really bothering me. All right. So what am I going to do for parts here? I'm going to get a little squished here, but I'm going to let u equal t. Okay, I'm going to let dv then equal e to the negative 0.05 t dt. I want to see you do this. So du is dt. I want to see your work for this, okay? I want to see that you, what your u is. I want to see what your dv is, all that good stuff. And then I'm just getting my calculator out because I'm going to divide. So v then is just this guy divided by the negative 0.05, right? So that's 20 e to the negative 0.05 t. All right, so we're going to take UV, so I have 100,000 still out here. We are going to get a little squished here, but I'm going to take U times V. So that's 20t e to the negative 0.05 t. Remember, this is a definite integral from like into 9.3. I must put my bounds. 0 to 5. So remember, I'm doing UV minus the integral of V du, right? That's what I'm doing here. In case you were wondering, you might wonder that often in this class. And then I'm going to subtract this v du. So minus the integral from 0 to 5. I apologize that this is getting kind of squished, negative 0.05. And what is my du? It's just dt, which is great. All right, so what I get, 100,000. If I plug in the 5 here, I'm going to get 100. Right, e to the negative 0.25. If I plug in the 0 into this t, that just goes to 0. And then if I take the antiderivative here, when I divide by the negative 0.05, there should be a t on that. I'm actually going to get plus 400, because that's another 20, e to the negative 0.05 t, evaluated from 0 to 5. Man, sorry, this is getting a little squished. So I get 100,000. I'm going to do that at the very end. 100 e to the negative 0.25. If I plug in the 5, I get plus 400 e to the negative 0.25, right? And then you must plug in the 0. Don't forget to plug in the 0, because e to the 0 is not 0. E to the 0 is 1. Now up here, why when I plugged in the 0, it went away? Because I had that t there. And then if you go ahead and do all of this, well, let me just do my calculator really quick. So I have I have 500, right? Let's make this easy on ourselves. E to the negative 0.25 and then minus 400. And so, ooh, this is a problem. Let's see, what did I get here? I have something wrong here. You guys probably saw this a while ago. I just had to pause the video and look at this. So again, this is a good learning situation for you, that even teachers make mistakes. I forgot my negative back here. Whoops. So this negative right here actually comes over here, makes that positive. Sorry about that. My goodness, that's embarrassing. You know what though? If that's the worst thing that happens today, I think I'll be all right. So then when I divide by that negative 0.05, this actually becomes negative right here. This is going to be much better now because I won't get a negative out, which is really, really good. So then when I divide, I get a negative 400. So if I put in the 5, I get minus 400, but this is going to be plus. So let me put this back in. So I get now 300 times e to the negative 0.25 plus 400. Oh, that's better. So I hope that makes sense. Sorry, not 300, a negative 300. One more mistake, and you can see right here, this should be a negative right there. Oh my goodness, this is horrible. Maybe not horrible, but okay, so what do we end up getting finally? I'm so sorry about this. If I take all of this right here, this ends up being, if I just kind of rewrite this, 100,000, and I had to pause the video and like find my mistake there. So I want you to notice that happens to even seasoned mathematicians such as myself. I don't know if I'm allowed really to call myself that, but I like to think it. Okay. Oh my goodness, that took way too long. Luckily for you, I could pause the video and see where I went wrong. But look at what this is saying then. My present value of my income, right? What my income presently is, assuming that over the next 5 years, it'll grow at an inflation rate of 5%. This is the amount of money that if I put it into an account like that and I assume this rate, this is what this income is worth right now. And so what is the income worth? Can the company claim that it's worth, present value of its income is at least $1 million? Yeah, it can, because this projection is about, $1 million and some change, if $60,000 is just change. Okay. So I hope that makes sense. I apologize for messing up on the negatives there. Man, that negative really threw me off. I forgot that one right there. That's why it's important to check your work. So, when I got the negative, that didn't make sense. What I actually noticed also was when I didn't have this negative right here, I was getting something like 16 million, which just wasn't feasible. If we're asking if we're at least $1 million, and it's 16 million, that's quite a bit different than what we would think it would be. Okay. All right. So the other application that we're going to look at in this section is this, I love this one, this next application. And you saw this was also one of your definitions, and the definition was a population ring, right? Maybe around a city, or you have a homework problem where you're looking at like the population of lava. I think that's pretty sweet. But the definition here is that the total population in a ring T, let's just say, in a ring around a city. I'm not even going to say a city, maybe around a center, because you're going to do a problem where there's lava. So I love saying that word too. Is given by this, and this is such a cool little thing. So we'll do P again for population, A to B, and we have 2 pi T dt, or d of t, excuse me, and then dt. Okay, what is that function d of t that we speak of? This is the density, okay, of the population of whatever we're dealing with. Maybe people, maybe not. Okay, in persons per square mile at a distance of t from the center. So the idea with this, and they do a pretty good job of showing you a picture, is what does this guy include? Well, if this is my center, and let's say I wanted to know, how many people actually live at a distance between A and B miles, maybe from the center of a city, what this does is it gives us the entire population. One reason this kind of works is, well, if you take 2 pi times t, well, t really is going to be your distance from, right? Your distance from the center. So it will include every single value. This is what the integral does for us, which is so awesome, is it allows us to take every single value of t, and then these bounds tell us where do we want to take those values. So if this is my a and this is b, then what this integral does is it just grabs every single t between a and b. I love that about integrals. That's so neat. And what this is, if you kind of notice some of this, the 2 pi t, if you remember, 2 pi r is the circumference of a circle. So basically what that t is doing is it's grabbing every person around the circumference of this circle, and then it's moving out a little ways and grabbing every person from this circle, and it's grabbing every single circle, every single possible circle, which is a lot of different circles, between A and B. And then it's multiplying it by the number of people that there are as it sweeps across the circumference. So kind of a cool, I think, kind of a cool application of the integral. I think that's pretty neat. So let's do an example. That probably doesn't surprise you that I think that's pretty cool. So in 1940, the population density t miles, okay, from the center of New York City. Sorry, you keep seeing my emails. Of New York City, okay, was approximately, I'm going to be a little lazy here, 120 e to the negative 0.2 t thousand people. So we got to remember when we get our answer, it's going to be in thousands of people, okay? Oh, man. Sorry about that. 1,000 people per square mile. Okay, so the setup is quite important here. And what we want to do is we want to estimate the number of people who live 2 to 4 miles from the center. Estimate the population living between 2 and 4 miles from the center. Okay, from the center of the city. All right, so again, these formulas aren't too bad. I'm going to give you these formulas on the test. You need to know how to use them. I won't tell you which formula, well, I might give it to you on the actual problem, but you need to know how to use it. So we'll go back to that population. I'm going to integrate from 2 to 4. Then I have 2 pi t times my density function, which this is my density function right here. So I get 120 e to the negative 0.2 t dt. And let's see if I can do this without making a mistake. I am not making any promises here. So I would have then, I'm going to pull out my constants. I just think it's easier to pull my constants out. So I'm going to have 240 pi is a constant, 2 to 4 t e to the negative 0.2 t dt. And as you see, we're going to do parts again. So I'll do my work over here. U is t, that means du is dt. dv is e to the negative 0.2 t dt. And I'm going to learn from my mistakes. And I'm going to take 1 divided by 0.02 is 50. And I need to put a negative. Negative 50 e to the negative 0.2 t. That's going to be what v is. So here's what we get then. I have 240 pi. Okay, now I'm going to multiply by uv minus the integral of v du. So I need to put parentheses here. So u times v will give me a negative 50t e to the negative 0.2t, and I'm going to evaluate the sucker from 2 to 4. It's very important that you put those bounds there. Then I'm going to subtract v du, but since I'm subtracting a negative, we'll make that a positive. I can even bring that 50 out if I want to. Why not? It's just a constant. Poor constants, they kind of get, no one cares about them. All right, and so again, good notation. I want to look for good notation. I want to see your work, and let's see what we get here. Let's see if I can do this without messing up. I am not making any promises here. So if I put in the 4, I believe 4 times 50 is 200. I think I can do that in my head. And this would be e to the negative 0.8, okay? And then when I subtract 2 times this, it actually becomes a plus. 2 times 50 is 100, e to the negative 0.4, okay? And then if I look here, what am I going to get? I'm going to get minus, and if I take 50 and divide it by 0.2, well, I get 250, right? And then I'm going to go ahead and then I just get e, so I'm going to be a little bit lazy here. I'm going to get a negative, and then yet I tell you, you can't be. But if you see what this is going to be, you know, you sure could go ahead and plug these in. This is the antiderivative, so I get minus 250 times e to the negative 0.8. If I plug in the 2, minus e to the negative 0.4. If I plug in, if I plug in the 4, now if I plug in the 2, and then, you know, I can think of this constant being multiplied times those bounds plugged in. All right, and so let's see what we get. So 240, and then you should have a pi key on your calculator, or you can just use 2.14 or 3.14 to estimate that, plus 100 e to the negative 0.4, okay, minus 250. Sorry, I keep getting all these emails. I need to turn that off. 250 times e to the negative 0.8 minus, now I'm using lots of parentheses here, e to the negative 0.4, because I want to make sure that I get this right. And I think this looks like it's the right answer. So my work, let's just put the answer up here. What I get is 24439.56685, but that's not my answer, right? That doesn't make sense that only 24,000 people lived between 2 and 4 miles from New York. So what is my final answer? I need to multiply this by 1,000. So I have 24439, and then move that decimal place over 3. This is how many people I have estimated living between 2 and 4 miles from the center, about 24 million people. And I apologize for that being all squished in there, but I hope that makes sense. Sorry about the calculator errors, how embarrassing. Oh well, you get over it, I suppose. And if you have any questions, of course, please ask. I promise I won't make too many errors when you ask me.